Hello and welcome back to Foreknowledge. In this session, we are going to focus on locus. Now, what is locus? Suppose you are given a point. Suppose you are given a point and the point is moving under certain condition or conditions. Okay, that means the point is moving with some given direction. Okay, so the curve that will be traced by the moving point that I mentioned earlier. That means you have a point and the point is moving either under some condition and a curve is being traced by the moving point. Okay, this curve is called the curve that is being generated, that is called the locus of the point. Okay, that is called the locus of the point. So that means a curve which is traced by a point which is moving under certain condition. That is the locus of the point. Simple. For example, suppose there are two fixed points A and B. Suppose there are two fixed points A and B. Now there is a moving point P. Suppose there is a moving point P and P is under such a condition that distance from A distance from A and distance from B are equal. This is suppose the point P. The condition is AP equal to BP. Now under this condition, suppose the point moves. Suppose after some time P is here. Okay. Why we are taking it here? Because again if we calculate the distance of P from A and the distance of P from B, that should be equal because this is the condition for movement of P. Suppose P is here, this is P. Suppose P is here, again the same condition. Because AP equal to BP. Okay. Suppose P is here. Again AP equal to BP. If we move on like this, then this P will trace a curve, or the movement of P will create a curve like this. Curve means here it is a straight line, here it is a straight line, and this straight line will be nothing but the perpendicular bisector of AB. This curve, this straight line where on which the P is moving will nothing but the perpendicular bisector of the connecting line segment A and B. This is the locus of P. Okay, the straight line that is drawn in the black. This is the locus of P. Consider another example. Suppose there are two fixed points S and S dash. Okay, and there is a point, moving point P, such that PS plus PS dash is equal to constant. PS plus PS dash equal to constant. That means PS and PS dash, this sum is constant. Suppose P is here. Again PS and PS dash will be constant. Suppose P is here. Again PS and PS dash will be constant. Suppose P is somewhere around here. Again PS and PS dash will be constant. So if we keep on moving like this, if we trace the entire way of P, then we'll get an ellipse. We'll get an ellipse. This ellipse, this elliptical structure, this is the locus of P. That's how, that's what locus means. Okay, locus of the point. That means P is moving under certain condition. The condition is this in this case. The condition was AP equal to BP in the previous case. We trace the curve and we get the entire picture. This entire picture is the locus of P. This elliptical path is the locus of the P. That perpendicular bisector in the previous example is the locus of P. Okay? So this is locus. Fine. But what do we do with it? How to solve this type of problem if we encounter one? Let's look at that. There is this type of problem that you have to encounter. That means you have to find the equation of a locus. That means you have to find the curve ultimately. Okay? You have to find the curve. So there is one algorithm for this. There is one algorithm for this. Simple algorithm. Simple algorithm. First one says we have to assume the coordinate of the moving point as h comma k. Coordinate of the moving point as h comma k. That we have to assume at first. Not xy, not ab, nothing. This is the conventional way we have to assume it as h comma k. Okay. Second is we have to write down the conditions in mathematical form. Write down the that means the AP equal to BP. What is AP? Distance of P from A. So the distance formula we have to write. We have P as HK, we have a coordinate of A, we have coordinate of B. So this AP is root under H minus X coordinate of A whole square plus Y minus Y coordinate of A whole square. This is the left hand side, and similarly the distance formula is the right hand side. That's how we have to write down the condition. Write down the conditions in mathematical form. Now, number 3, whatever variables present apart from h and k, try to eliminate. Eliminate all other variables except h and k. Okay, and finally, once you are done with this, finally replace replace h comma k by x and y respectively, and we get the equation of the locus. So after elimination, we get a relation of hk, and with some constant values, we eliminate or we replace x and y in that equation where we have h and k. So that's how we proceed. Now let's solve a problem. This was a previous year question, 2020 question. We are going to solve this. Okay. So let me erase this one. I'm going to write down the question. The question says the locus of the midpoints of the perpendiculars drawn from this is perpendiculars. Okay, this I'm writing this sign. This is perpendiculars drawn from the points on the line y equal to x equal to 2y to the line x equal to y is, that means we are drawing perpendiculars from the points on this line x equal to 2y to this line. Okay, we have to find the midpoints of those perpendiculars, and we have to find the locus. That's it, we have to find the locus. There are four options: 3x minus 2y equal to 0. Number 2 is 5x minus 7y equal to 0. Number 3 is 7x minus 5y equal to 0. Number 4 is 2x minus 3y equal to 0. Though it is a joint entrance problem, I am going to solve it elaborately. Okay, I am going to solve it elaborately. This is the question. Just copy it down, because I need the board to solve the problem. It is a big problem if we solve it conventionally. Okay. Shall I erase? Okay. First, let us draw the diagram. You need to understand what is happening here. Okay. Now, x equal to y means the lines which are passing through origin and its slope is 1. So, passing through origin and slope is 1. Okay. Y equal to x. And this line x equal to 2y, that means here the slope is half. Y equal to mx plus c, compare it. Y equal to half x. So m is half, that means the slope is less than 45 degree. The slope is less than 45 degree, x equal to 2y. Okay. Now what we are doing, what is the problem saying? The problem is telling us that we are drawing perpendicular from the points on this line to this line. Okay. Suppose this is the point, we are drawing a perpendicular here. Okay. Suppose this is another point, we are drawing a perpendicular here. Okay. That's how this is going. Now we have to find the locus of this midpoint. This is the perpendicular. Its midpoint is, I am denoting it as HK because the algorithm says so. So this HK, we have to find the locus of this HK. Here, this is the point P. Also, this was the midpoint here, H comma K. Okay. So how the point is moving, how the midpoint is moving, that is what we have to find out. Okay. The equation we have to find out. Fine. So we can take this point as what? 2 alpha comma alpha. Okay. Because if y value is alpha, then x will be 2 alpha. So 2 alpha comma alpha can be any point on the line x equal to 2, 1. Okay. And beta comma beta, I am taking randomly alpha and beta. Beta comma beta can be any point on the straight line y equal to x, because if you put y as beta, then x will be beta. So beta comma beta will be any point on the straight line y equal to x. Fine. Now, what does the question says? The question says locus of the midpoints. That means HK is midpoint of 2 alpha comma alpha and beta comma beta. Okay. So that means H is nothing but 2 alpha plus beta by 2, and k is nothing but alpha plus beta by, okay, h is nothing but 2 alpha plus beta by 2 and k is nothing but alpha plus beta by 2, midpoint theorem. Okay, hk is midpoint of 2 alpha comma alpha and beta comma beta. Okay, from here let's find alpha. From here let's find alpha. So what is alpha here? 2h minus beta by 2, this is alpha, and from here 2k minus beta, that is alpha. Okay, 2h minus beta by 2 is alpha and 2k minus beta is alpha. Okay, from this equation, this is number 1. This is number 1. And in the second one, second condition, what we are getting, that this line, this perpendicular is perpendicular on which line? Y equal to x. Okay, so slope of this line, slope of this connecting line into slope of y equal to x, since they are perpendicular, the product of their slope will be minus 1. So let's take this. So k minus beta, how do we find the slope of a line which is passing through two given points? Y2 minus y1 by x2 minus x1. So k minus beta by h minus beta into, what is the slope of y equal to x? Slope of y equal to x is 1, that is equal to minus 1. Okay, that is equal to minus 1. So from here we are getting k minus beta equal to minus h plus beta. So h plus k equal to 2 beta. This is equation number 2. This is equation number 2. Now what we have to eliminate? We have already eliminated alpha because both alphas are equal. So from here we can write 2h minus beta by 2 equal to 2k minus beta. Since both alphas are equal, so 2h minus beta by 2 will be equal to 2k minus beta. So alpha is already eliminated and we will use this relation to eliminate the beta. Okay, so now let's simplify. So 2h minus beta equal to 4k minus 2 beta. That means 2h minus 4k equal to 2h minus 4k equal to minus 2 beta plus beta, that means minus beta. Now beta is h plus k by 2. From here beta is h plus k by 2. So this is nothing but h plus k by 2. So consider this and this. Simplify. Just simplify. Nothing more, nothing less. So this is nothing but, these two will be cross multiplied. So 4h minus 8k equal to h plus k. 4h minus 8k equal to 8 plus k. Sorry, h plus k. So this is nothing but 3h minus 9k equal to 0. I think I have made a mistake. Just allow me. Just allow me. This is 2 beta. This is 2 beta. 2 alpha plus beta by 2. Fine. Just allow me. 2h minus beta by 2. Okay, fine. 2k minus beta equal to alpha. So 2h minus beta by 2 equal to 2k minus beta. So 4k minus 2 beta. So 2h minus 4k equal to minus beta. Oh, sorry. This should be a minus. Just allow me. I made one simple mistake, that is this is equal to minus h plus k by 2, because this is minus beta. From here what are we getting? We are getting beta as h plus k by 2, but here it is minus beta. So basically this is minus h minus k. So the final answer will be 4h plus h, that is 5h, and this is minus 8k plus k, that is minus 7k, equal to 0. Okay, this is the hk relation after elimination of alpha and beta. Fine. Now the final answer, what we have to do? We have to replace the hk by x and y. So the final answer will be the locus of the midpoints will be nothing but 5x minus 7y equal to 0. This is the locus of the midpoint. That means the option B, the option 2. Okay. So there was a little mistake in the last step of the problem. So just don't skip the part. I have corrected it. So this is the answer. So that's how we solve a problem on locus. That's how we solve the problem on locus. I hope this is clear. This is a conventional way. Okay. So if you are studying in class 11, this is a topic in your course under the coordinate geometry. So I think this will be helpful to you. So if you like the video, please let us know, and we'll be keep on updating our playlist. Thank you. See you soon.